Yes, student. Now, in the next video, besides of writing more, I am concentrating in explanation. Okay, it is because again I am telling you the notes are already given in the previous content. Okay, and the contents are the same. That is, the related contents are there. Therefore, need not to write more and more. Like here, oxides are sextile group element. Now, you know that the sextile group element have general electronic configuration NH2NP4. That is, they shows two type of state. What? +4 state and what? +6 state. Getting here, the oxides means oxygen, the reaction with oxygen. Getting? So oxygen is a divalent. Oxygen is a divalent, therefore it forms, that is, all sextile group element form two type of oxides, dioxides and what? Trioxides. In dioxide, can you think about O? So the O, that is the first element, S is the second element, and Te is the next element, and so sorry, Se is the next element. So oxygen already exists in the form of O2 only. So that will not considered as dioxide, but it will considered as what? OO2. OO2, that is dioxide of oxygen, like sulfur dioxide, like SeO2, and so on. But if you think about trioxide, you can call O3 as a trioxide, similar to it, but here you can call what? SO3, and here you can call it what? SeO3. So this type of dioxide is formed. Getting here the structure of SO2 and SO3 we can discuss here. Like in the case of sulfur, okay, sulfur, it has 6 valence electron, 1, 2, 3, 4, 5 and 6. And the oxygen has valency what? 2. Therefore it forms 2 double bond with oxygen, along with there is one lone pair. But now the lone pair bond pair repulsion is little large, and therefore the bond angle is 119.5 degree. But if we deal the case of SO3, now again as 1, 2, 3, 4, 5, 6 valence electron, but 3 oxygens are there, therefore this is O, O and O. So the double bond is formed with 3 oxygen atom. That means it is completely what? Trigonal planar. Therefore the bond angle is 120 degree. Are you getting? Further, you know, student, the structure of O3. Last year we have discussed already the structure of what? O3. In the structure of O3 or SO2. O3 or SO2. These are the simple structure. Like here O, that is double bond, and this is what? Lone pair. 1, 2, 3, 4, 5, 6, 1, 2, 3 and 4. Okay, but it shows what? A resonance, and due to resonance one more structure is possible where the displacement of double bond takes place, I mean pi electron pair, and lone pair takes place, forming one more structure. So 1 and 1, 2 structures. Similarly, the 2 structures are possible for SO2. But being the 2 structures are unstable, therefore we are drawing one more stable structure. In this structure, there is a resonance. Due to resonance. Okay, all the bond length in O3 molecule and even SO bond length becomes what? Similar. Actually, here it looks like there is 2 type of bond length. What? OO single bond or OO double bond. If the bond length is of single, then it will be higher bond length. But if it is double bond, then it will be shorter bond length. But the experiment shows that there is no 2 different type of bond length. The bond length is simple. This can be explained on the basis of resonance. So this question is also given in the in-text, like show that in O3 molecule and SO2 molecule all bond length are equivalent. So we can say yes, it is equivalent. This is due to this molecule shows what? Resonance. Getting? Next one, chemical properties. Chemical properties. Okay, oxides of 16th group shows reducing property, reducing property as well as oxidizing property, as well as oxidizing property. Oxidizing property. Now, how it is possible? If we see SO2, SO2, in SO2, S is in plus 4 state, while student, you know that S is more stable, in which state? Plus 6 state. It is because these are the lighter element. So S4 is what? Less stable, while S6 is called more, S6 is called more stable. See, this is what? Unstable, and this is what? Stable. That means what? That means it can easily release 2 electron, and being it can easily release 2 electron, therefore it acts as reducing agent. So sulfur dioxide readily reduces potassium permanganate, potassium dichromate in aqueous and what? Acidic medium, because it can convert into plus 6. But student, you know that down the group the stability of plus 6 state decreases and the plus 4 state increases. We have learnt it. Why? It is due to inert pair effect, and therefore the higher element, like we can say TeO2, okay, here Te is more stable in what? Now plus 4 state. So it does not act as reducing agent, but it act as, so it does not act as reducing agent. Besides of it, it act as oxidizing agent. So it become one more very important question, and you have to give the explanation. This is due to inert pair effect, which we have already checked.